Hello, everyone, and welcome to another session with Analytics Velocity. I am Aditya. The objective of today's session is a bit more technical than the last couple of sessions. We will focus today on a very simple explanation of how the logistic regression functions. So, one of the two preliminary methods which get taught in any machine learning course is the first would be the linear regression, and the second is the logistic regression. Now, what is the main difference between these two methods? It's actually a very important interview question as well. And the major difference basically lies in simply the dependent variable. So if I just go to the screen, so essentially a logistic regression takes note of when the dependent variable is binary in nature. That is 1, 0. It can only assume two particular values. It basically originates from the original concepts of the Bernoulli distribution. And from that, we assume that only one of two values are possible. This is completely in contradiction to what we had done for a linear regression earlier in one of my earlier videos, whereby the dependent variable is continuous. It can take on any number of values in a particular range. So what you see here is the general form of the probability P, which we estimate through a logistic regression. And it is done through something called the sigmoid function. And the objective is to use the logistic regression to estimate probabilities and to keep the probabilities between 0 and 1. And hence the use of the sigmoid function, which you see here at the bottom of your screen. This enables the estimation of probabilities of one of two events occurring. So there are a wide variety of cases in which a logistic regression is applicable. And one such case would be what I'll show you right now, which is basically the whole case of attrition. So in case of attrition, which is a very common use case nowadays when it comes to logistic regression, we have only two possibilities. Either we have a person will leave, which becomes a 1, or the person will stay on in the organization, which becomes a 0. An alternative application of the logistic regression would be through the effect of a marketing campaign. So either the marketing campaign will be successful in converting a particular individual, or it will fail. That's how we basically go into campaign analytics. So logistic regression basically tries to handle yes-no situations, whereby a particular situation will either occur or not occur. These success-failure outcomes actually originate from the concept of the Bernoulli distribution. So we talk a lot more about this during our batches here in Analytics Velocity. But the idea of the logistic regression is to completely cater to a two-situation case. Either it converts or it fails, as in the marketing case, and does not consider the third possibility. So if you consider a third outcome, let's say for a campaign, being convert, fail, or let's say uncertain, then we graduate to certain other modeling techniques, such as a multinomial regression or a random forest or a decision tree, as the case may be. But in this two-class outcome, whether it's only 1 or a 0, it is binary, is what we call a binary outcome, we invariably gravitate to what is known as the logistic regression. So always you need to keep in mind that a logistic regression always basically works out in a 1-0 outcome. A 1-0 outcome, also known as a binary outcome. The moment it is no longer 1-0 in nature, there is a third or more possibility. We basically go into something called a multinomial, a decision tree, or random forest, as the case may be. So the objective here is to determine the probability of, let's say, attrition happening, and this can depend on a variety of independent variables. So here it doesn't change to what it was in case of a linear regression. The independent variables can take a variety of forms: ordinal, categorical, continuous, as the case may be, and they all determine the classification. So basically, the logistic regression falls under a class of models known as classification, which we discuss in more detail during our lengthy sessions at Analytics Velocity, which we eagerly hope you join. So now, how do we actually proceed with a technique like this? So if it's, since it's probability oriented, you would expect there's a lot of background technical work going on, right? And yes, that is indeed the case, but it's made easier for us. It's made easier for us by Python. You can use R or Python. Python turns out to be the most popular technique which we use in looking at logistic regression. And for that, we just show you the code. For that, we look at the Python code, which invariably invokes the original description of a logistic regression and helps you to do a classification. So the code is a bit lengthy. So we go into that in detail when in class. So here we basically draw the necessary packages which we do obtain in order to partition the data, in order to invoke the logistic regression function. We also form the necessary data frames. We divide the data into continuous and categorical, as the case may be, so that to make it amenable to the logistic regression classifier within Python. We partition the data, as you see over here, which is a bit different from what we do in its original form in R. And then we apply the logistic regression, right? And we apply the logistic regression, and what you see here is basically the end result of the classification outcome. So this is what we refer to as a confusion matrix, which is nothing other than a cross tabulation between your actual and predicted outcomes. And it helps to determine how many of the actual cases did the model predict correctly. So that is exactly what this metric recall here does here. So out of all actual cases, it predicts 84% correctly, which is a pretty good situation if you're actually exploring any sort of business problem. So in this particular case, it was the admission of students into colleges. So as you can see, the logistic regression is quite simple. The code is something which is easily explainable. We'll talk about it in more detail. We'll go line by line in explaining it, and to tell you about not only the theory of logistic regression, but also about how to code it out and get model results. We have several evaluation measures as well, like the ROC curve, which we'll explore in more detail in class. And so this was basically a snapshot of how logistic regression works. A very terse representation, both at the theoretical level, in the business frame, a business problem level, as well as in terms of the application of the core code and how to evaluate models. We'll talk about this in considerable detail, in granular detail, both in terms of theory, both in terms of business problems, as well as in terms of the code in Python, as to how the logistic regression is run during our courses in analytics philosophy. So we hope you join these courses if you're eager to learn about the most preliminary technique in machine learning, which is the logistic regression, right? So we have included our website, our Facebook page, as well as our other coordinates along with this video. So in case you are interested to know about the logistic regression in detail, both at the theoretical level as well as in Python, do feel free to reach out to us. And I'm sure it will be an enriching experience, as you'll get a well-rounded view of how machine learning works. Till then, thank you and stay safe.